Hi everyone, my name is Nina Karikalan. My matrix number is CF2301. I'm here to summarize and elaborate what I have understood in this project. According to our group members' discussion, we choose the project in permeability. Firstly, what is permeability? If a substance contains continuous space, it is considered to be permeability. All soils, including the hardest clay, have these holes, and nearly all non-metallic construction like granite and clean cement are permeable. Our task is to search 3 case studies each person and summarize what we understand in the specific case study. I choose permeability of clay soil, treatment with lime and cement. Secondly is permeability by textbook. Thirdly is a field method used by a Walter David Murphy to determine soil permeability. The first case study is about the report delves into the permeability of clay soil subjected to treatment with lime and cement, employing odometer tests like flexible wall permeability test in laboratory setting. Secondly, the case study that I've chosen is a report in permeability by the test book provides a comprehensive overview of the intricate relationship between the soil permeability and various soil types based in grain size. Thirdly, the case study that we choose is about the report explored a novel field method developed by Walter David Murphy to determine soil permeability, offering a creative alternative traditional techniques primarily applicable below the water table. Thank you.
Hi, my name is Yawan Izam binti Jawa Mahmud. I will summarize of this project. Upon completion of this project, new knowledge about soil permeability can be gained. The study can be divided into several key points. First, soil permeability and its importance. It discusses the critical role of soil permeability in engineering and construction, particularly in designing clay liner. It emphasizes the need to consider various properties and factors, including the composition and structure of clay, to achieve the desired mechanical strength and impermeability. Second, factor effective soil properties. It highlights that the property of mixed soil materials such as sand and clay cannot be solely determined by the attribute of their constituent. It underscores the complexity of predicting the property of this mixture even the established empirical critical in some field. Third is laboratory measurement technique. The study investigates fully head tests in laboratory setting which offer a more straightforward and less error-prone alternative for permeability measurement. It also addresses the limitation of this method, especially when dealing with small sample size. Last, clay liner design. It's important of careful laboratory testing to obtain accurate permeability results for designing effective clay liner. This is crucial for managing soil consolidation and ensuring structural stability. In summary, it provides insight into the complexity of soil permeability measurement and its implication for engineering practice, particularly in designing clay liner and enhanced soil property for improved hydraulic stability.
For the first case study, the conclusion highlights soil composition impact on stability and permeability, emphasizing its role in agriculture for efficient soil management and sustainable practice. For second case study, Iranian study used a novel structural device to analyze unsaturated seed sand soil permeability, finding that higher fine material concentration decreased permeability with implication for geotechnical and environmental practice. And the last one is case study 3. The texture influenced by soil particle size, defined permeability, and water holding capacity. Soil structure impacts microbial activity, nutrient accessibility, and bulk density, crucial for eco-friendly farming decision. And with that, I want to thank to my teammates for the great teamwork, and also thank you to Dr. Anand for teaching us.
Review by me, which is my name is Nur Alia Shaira binti Abdul Ghaffar. The first one is probability coefficient of soil prediction and research using the aided single machine learning algorithm. The study analyzed the effectiveness of machine learning in predicting soil permeability coefficient in geotechnical engineering. Five machine learning methods are used, including gradient boosting, random forest, like GBM, k-nearest neighbor, and support vector machine. The GP model achieved the exceptional accuracy with factors such as density, plastic limit, void ratio, and clay content having the most significant effect on predicted permeability coefficient. The plasticity, the plasticity index and soil density were in, were identified as crucial factor for the reliable forest forecast. The next one is shelly sand permeability. This study examines the probability of shelly sand and shell combination. It identifies key factors such as a shale percentage and member probability, porosity, grain diameter, and electrical cementation exponent. The study used various models, including clay-free sand model, pure, pure, pure shale model, and sand shale mixture model. The study concluded the shale percentage determines permeability with the lowest at the critical shale concentration. Advanced modeling approaches are needed for precise prediction due to the complex interaction between parameters. The next one is soil and soil physical properties by unknown. Probability, the rate at which water percolates through soil, is crucial for the safe irrigation rates. It is influenced by factors like soil texture, structure, salt content, organic matter, fine texture soil, calcium, and soil organisms. High irrigation rates can cause soil crushing, runoff, erosion, and fertilizer loss. And the last but not least, special thanks I want to give to my group members, projects, especially Sajwani and Ashira. They helped me a lot in this group project when I'm busy with university programs. That's all from me. Thank you.
Review for the porous nature of clays and slates. Number 1, matches can reduce permeability in clays and shales. Number 2, faults and fracture often compensate for reduced permeability on a larger scale. Number 3, permeability based on geological settings and petrophysical characteristics. Number 2, review a study by Jiawotang. Number 1, a soil permeability prevent instability and hydraulic instability issues. Number 2, TST55A parameter and following head test used to study soil permeability. Number 3, lower permeability coefficient correlates with increased stability. Review a relative examination of the M5P and GP for soil permeability coefficient prediction. Number 1, M5P perform more accurate than GP. Number 2, indicate the practical of machine learning technique for predicting fundamental soil parameters. Number 3, emphasize the potential of soft computing in geotechnical assessment.